So now we're going to go on to the retrieval task. So what I want you to do, I want you to answer all 3 questions. Let's see if we can retrieve that information. So something we've covered last month, last week, and what we covered probably yesterday or the day before. If you want to get on with that for me, please. So we'll give you 3 minutes on that. How are you finding this, ladies? Yeah? All right with the bearings. Can you retrieve that information? Yeah, good. Ladies, how are we doing? All right? Yeah? Really well done, Year 10. Right, so on your boards, can you please tell me what the bearing is of B from A? Put them up in the air. Just double check that for me, please, Fatima. Well done, ladies, brilliant. Just double check how many digits are bearings in. Just check your answers again. You've got the right number, but how many digits is bearings? Well done, ladies. Well done, gents. How are we doing, Josh? Think about it. Well done, gents. Just double check that for me, Tiana. Well done, ladies. Brilliant. So, when we're looking at bearings, we need to check from our north and what rotation do we go in? What direction? Clockwise. Well done. So, it wants it from A. So, here's our A, our north, going clockwise. We want this. What type of angles are these? Can you remember when we're looking at parallel lines with a transversal, saying what type of angles are these? Co-interior, well done. And in co-interior angles, what do they add up to? 180, well done, Connie. So, from 180, what am I going to do with my 113 degrees? Take it away. So, as the majority of you said on your boards, you were left with 67 degrees, which in bearings is 0.67 degrees. Well done. Right, Dexter says the bearing of X from Y is 113 degrees. Why is Dexter incorrect? Well done. Well done. Brilliant. Fantastic. Well done. Fantastic. Brilliant, Ishal, thank you. Yeah, I can see the majority of you have noticed what Dexter has done wrong. So he's seen it from Y here, and he's measured anti-clockwise. When, as we stated in question 1, we need to go anti-clockwise. Okay? So always remember the rules. From north, we measure clockwise. All right? And last question, solve 3y plus 12 is less than and equal to 30 minus y. On your boards, well done, well done. Brilliant, brilliant, fantastic. Brilliant. Well done, guys, well retrieved. Brilliant. So, who wants to start me off on this problem? Anybody? Sam, thank you for offering. So, what do I need to get rid of first? The 3y or the minus y? Well done. We always get rid of the smallest. How do I get rid of that minus y? I do indeed. I add y. Is that it? Well done. What I do to one side, I have to do to the other, so add y. Okay, so that gives me 4y. I'm just going to throw it up here because I'm running out of room. 4y plus 12, because we didn't do anything with that, is less than and equal to 30. Minus y, add y, takes us to 0. Do you want to carry on? And then we take away the 12 from this side. So, take that 12, because I don't want to get rid of that one. Sorry, I'm over here. Take that 12. Take that 12. 4y is less than and equal to 9. Hang on, bear with me 1 second. 18, sorry. Then what do? Divide by 4, because 4 times y is less than or equal to 18. Divide by 4. Divide by 4. Y is less than and equal to 9. Fantastic, year 10. Right, what we're going to do now, we're going to move on to the main content. Have you all got the lesson objective in your book? Understand and use the volume of a cylinder of a cone? Yep, everybody got that? Right, let's learn these skills, what we need for this content. So, can you all raise your hands if you know how to find the area of the circle? Brilliant. Do you know the formula, Josh, to find the area of a circle? Pi times radius. Well done, it is indeed. It does want it in terms of pi. Okay, so what we need to do is just substitute the radius. Is this the radius or is this the diameter? It's the radius because it's half of the diameter, isn't it? So pi times by 4 squared. Put your hands up if you can answer that question for me. What is 4 squared? Put your hands up. Gemma? 16. So I've got pi times 16 squared. And I just get rid of the times. So, sorry, it's not squared. 16 pi. Measurements, millimetres squared. Okay, so can you please write this in your book, as long as you know how to find the area of a circle? Please write that down. Right, has everybody got that written down? Fantastic. Right, volume. How do I find the volume of a triangular prism? Well, first of all, let me just go into a cube. I know the question states it wants a triangular prism, but then I want to prove it to you why we do the last part of the formula. So, I have drawn 2 triangular prisms. One here, which has now formed a what? What shape? A cuboid. Well done, Lucy, thank you. I've now formed a cuboid. Who can tell me how to find the volume of a cuboid? Fatima.
So you times 3 times 4 times 5 divided by 2.
So why did we divide by 2? So that proves my fact there, whereas in I drew another triangular prism on top of there. What have I done with the cuboid?
You found the volume of the rectangle, but you need the volume of the prism.
Fantastic. So I've got the volume of the cuboid, but because it was split in half, that's why we half it. Really well done, Fatima. That's a really good answer. So again, we're going to be working with the area of a cross-section times by the length. So as long as we can find the area of 2D shapes, then all we have to do is multiply it by the length. Let's go into the main content. So, cuboids. We need to know the facts of a cuboid. So, cast your minds back, try and retrieve that information. Can anybody give me some facts about a cuboid? Not a cuboid, sorry, a prism. Can anybody tell me something about a prism? What's it made up of? What 2D shape is it made up of? Rectangles, well done. And what does either side of the prism have to be? Say that again, sorry, Libby. The same, indeed. Okay, so that's how we form a prism. So, is this a prism? Yeah, indeed. It's got the same on either side, and then it's made up of rectangles. Is this a prism? No. Why? It's 2D. What about this one? See, we could argue that, but you are indeed right, it's not a prism, okay? Because what we need to do, if we actually split it in half and open it up, it would make a rectangle, but the shape has to be made of rectangles. And what about this one? No, again, it's not made up of rectangles, is it? So everybody's clear on prisms. Okay, let's move on, year 10. So, I have a cylinder here. Calculate the volume of the cylinder, giving your answer in terms of pi. So, show of hands, please. Who knows how to find the area of a circle? Hopefully we all should have our hands up. refer back to your book to find the area of a circle. Thank you, Fatima. So we use pi times by radius squared. That has found us the area of this circle. Volume is the capacity within a 3D shape. So if you imagine that I got this circle and pulled it down, that would fill it, wouldn't it? Yeah, because there's so many circles that fill this. So if I can find the area of that circle, what do you think I'd do to actually find the volume? There's one last part to this formula. Libby? Well done, because if I can find the area of this circle and then times it by the height, that gives me the full volume of that cylinder. So pi times radius squared, in this case, what's the radius? 5. So pi times by 5 squared. Who can tell me Mahid, what is 5 squared? 25. So I've squared it, 25 pi, because it wants it in terms of pi. And then, as Libby said, I'm going to times it by the what? Shout at me. The height. That will tell me the full capacity of the cylinder. 12. Can you make a note of that for me, please? Right. So let's break that down, just as I've done. So the circle with a radius of 5 centimetres, square it with pi, and then we times it by 12. So we have 300 pi, because it wants it in the terms of pi. But if it wanted it to 3 significant figures, I'll give you the answer. If that's when you press SD on your calculator, that's what it give it you as a decimal. Who can tell me, I want a show of hands, who can tell me what the first significant figure is? Put your hands up when you can tell me what the first significant figure of this answer is. Talia, what's the first significant figure of that answer? Not necessarily. Think about the highest place value, Talia. What's the highest place value here? What number is in the highest place value of this number? 9. Okay, so our first significant figure always starts in the highest place value, but only if it's above 0. Because say, for example, just quickly, if that was a 0, has it any significance? No, so we'd have to move on to the next number. But as Talia said, the highest place value has a 9 in it, so that would be my first significant figure. What's my second significant figure? 4. And then it just carries on, even including zeros on the way. Third significant figure. Fourth significant figure. So I'm just going to leave it there because it wants it to 3 significant figures. All right. So I'm going to cut through these numbers because the 4th significant figure tells us whether or not the 3rd significant figure changes. Put your hands up if you think this changes to a 3. So I'm sure that you're all saying no. You're right indeed, because that's less than 5. 5 or above, give it a shove. 4 or below, let it go. So you would indeed get 942 centimetres cubed. Okay? Right, I'm just going to push on a little bit. We all know now the volume of a cylinder is equal to pi times radius squared times by height. I want you to write that down shortly, but I want to put it all together because we're going to go into cones soon. So, can anybody quickly spot the mistake on there? Tiana? Fantastic. So they've done the diameter, not the radius. And again, to find the area of a circle, it's pi times radius squared. They've done the pi times diameter squared. Well done. Okay. Right, moving on to cones now. So we've looked at cylinders, but what I want to do is give your attention to this. If the radius of this cylinder is 3, and the radius of the cone is 3, and the height is 10 for both of them, what do you notice about these? Same with this one. If the radius of this cylinder is 4, and the radius of this cone is 4, and the heights are the same, put your hands up when you've seen what happens with the volume. Have a think. So what has happened? What's the 30 to the 90 and what's the 64 to the 192? Libby? divided by 3. Well done indeed. So 30 is a third of 90, isn't it? As is 64 is a third of 192. So there's proof for year 10. The cone is a third of the volume of the cylinder. So again, when our radiuses are the same and our heights are the same, the volume is a third. So what I want you to do now, year 10, is I want you to copy this formula for a cylinder. So write cylinder, oops, can't spell. Cylinder, the volume is equal to pi times radius squared times by height, and this is the volume of a cone. Okay, so you've been given a handout of a cone and a cylinder. Underneath that, can you please write the formulas for them? Your work is so neat. Keep that up, machine. You are doing amazing today, year 10. And I'm just looking around some of your work. Your work is absolutely amazing. Keep up the good, hard work. How have you found this, Tiana? Is that all right? Good girl, brilliant. Owen, how have you found it? Is it good? Brilliant. So when it comes to revision, I want you to go over these, please, because again, catching formulas are the best revision that you can do, okay? Because maths, the majority of the time, it's about formulas. Making sure that we can retrieve that information and put it into a problem. So, what I want you to do now, I'm going to give you each a calculator. I want you to work out the volume of the cone, giving the answer to 3 significant figures. So again, refer back to your book, the information that you've been given, use the formula you've been given, and work out the volume of that cone. And remember to give your answer to 3 significant figures. Well done, ladies. Well done, guys. So what have you found with this, Connor? Well done. Fantastic. So quick, speedy work. Do you want to join us? So what's the formula? What's the formula to find the volume of a cone? Well done. So again, it's a third of the cylinder. Half an hour. Thank you so much, and I've got you. Just stay there. Fantastic. Right. So, what did we get? Josh, what did you get? Well done. Yeah, but 3 significant figures. So we don't want it in terms of pi, but what did you get it to 3 significant figures? Well done. So, a third of pi times radius squared times by height. So again, looking at this formula, the formula to find the volume of a cylinder, but then we divide it by 3, which is a third. So again, looking into it, substituting all our information, the radius being 4, so 4 squared, times by 9, and then a third would give us 48 pi, as Josh said, centimetres cubed, but then we want it to 3 significant figures. That 7 takes that up to a 1, giving us 151 centimetres cubed. A fantastic effort. What we're going to do now, year 10, we're going to go on to the LBQ question set on volume of cylinders, cones and prisms. Yeah. Yes. And then what I want you to do is write the code down, what I'm going to write on the board for you, and then you can show all your working out in your book. Okay? Thank you so much. Ladies, a fantastic effort today. Really well done. Gentlemen, you've done amazing. Sam, your answers were fantastic. Libby, you've done really well today. Ladies, thank you so much for your hard work. Lads, I'll just give you them and let's go and get some more. There we go. I'm saying it's not a mirror, it's a learning tool. Your hair looks fine. Yes. There you go. So, there is your chord. Yes. It's not turned on. Oh, it's okay, okay. I'll get you another one. And then you just add all your details. Tell you how. Yes, I'm going to put it up for you now. Not that chord, sorry. It's just so when I come to marking your work, if I've got the chord in your book, I can see your results. So, I want you to write in your book 10176. So this is the chord that triggers this. There we go. Yeah, I'm more than happy for you to work together. I feel you working together will really help your learning. So make sure that you're working together, or you can work independently, that's absolutely fine. Well done, fantastic. Year 10, readings ready? Right, so I'm just going to pause you for a second. So what question are you struggling with, Tiana? Question 6. Well, I can see a lot of people are struggling with question 6 because it's now going amber. So we'll have a look at this. So can I have all tablets down, please? Let's have a little look at it. So here we have a compound shape. And again, volume's about the capacity that fills within the 3D shape. So what we need is the area of the cross section. And who can retrieve that information? What do we multiply it by? We multiply it by the length. So, in order to find this compound shape, I need to break it up into 2 different 3D shapes. So if I say this part is one shape, okay, so we've got a cube here, and now here we have a cuboid. Okay, so let's find the volume of both shapes. So let's do the cube first. So the cube, what's the area? Well, if this is 2, can you see where it 2? So the height is 2 and the base is 2. To find the area, we do 2 times 2. Who can tell me what the area of the cuboid is? So have a little look. I've done the cube for you. Think about it. What's the area of the cuboid? Tell you. Say again. Is it 8? Have you added them? Oh, sorry. Yeah, sorry. Yeah, because you've done 4 times 2. Apologies, my mistake. So 4 times 2 equals 8 centimetres squared. And then, where we have it, we have to times these by the length. So, if you can see, we've got 12 centimetres squared, the area of the cross-section, times that by 2 to find the volume. So, area of the compound shape is 12 in total, times by the length. What's the length, year 10? 2. So if I did 12 times 2, I get 24. And just let me prove that to you. How many cubes are in here altogether? Well, if you look here, 1 cube, 2 cube, 3 cube, 4 cube, 5, 6, 7, 8, 9, 10, 11, 12. That's the first row. So there's 12 cubes on the first row. It has 2 rows, another row going back. So that must be another 12 cubes. So the volume of that compound shape is 24 centimetres cubed. Does that make sense, Tiana? Fantastic. Right, we'll unpause you. Off you go. Again, ladies, you're more than welcome to work together. You all right, lads? Yeah? Good. Let's just have a little look how we're getting on. Wow, look at all those greens. Those greens are showing that you've retained that information. Some really good work there, Year 10. Well done. What question are you on? Well done. Speedy work. Stuff. So let's have a little look. So let's break it down. All right. So again, let's break it down. So here we have a rectangle, don't we? Yeah. The base is 5. The height is 3. So we'd find the area of that. Yeah, because not necessarily, because if you look here, 6. So that would be 6. Yeah. So let me just draw that in your book. So there's the compound shape. Yeah. Don't worry, I'll cover this up. So that part, this part must be 3 centimetres, mustn't it? Because we have that here. Yeah. So if I brought that down, so that must be 2. Yeah. Find the area of this one, which is 3 times 3, which is what? 9 centimetres squared. And what's the area of this one? 12 centimetres. Libby, how can I help? Righty-o. Well, it's already told you the area of the cross-section. So what is the... So the cross-section is basically the front face. So it's the area of this. Yeah? So if we find the area of that, it's how many of them fit into that altogether. So what am I going to times the area by? 1.5. The length. Yeah, so that'll tell you how many of them triangles fit into that 3D shape. No, because it's already told you the area. So it's worked it all out for you. All right, so all you need to do then is times the area of the cross-section by 10.5. Does that make sense?
Do we do it to a decimal?
Does it? So it tells you not to include the units in your answer. So calculate the volume in triangular prism. You'd write it like that. A pen anywhere, it's there. It's the cheeky pen. Ishal, how can I help? Righty-o. So half of AB times, so that's the area of the trapezium. All right, so yeah. Right, Year 10, can I stop you again, please? Because there's quite a challenging question. Sorry, Ishal, what question was it? 16, again, is... So I'm just going to pause you for a second, Year 10. So reading's ready. Eyes, ears, arms, back to me. Thank you. So, just let's have a little look at this question. So again, trapezium's the hardest formula of area, all right? It does tell you what the formula is, all right? But what I want you to do now, in your book, can you just draw me this face in your books? A trapezium for me, please. So all I want in your books, using a pencil and a ruler, is a trapezium. And then I want you to label it for me, please. So A, B, and the perpendicular height, H. So, when it comes to finding the area of a trapezium, Year 10, it's the sum of the parallel sides multiplied by the height and half it. I'm going to do A and B. So this is A, this is B. Because if you see, these are the parallel sides. These aren't parallel, are they? They're not parallel because they are going to meet at one point, okay? So what we do, we find the sum of the parallel sides. So A plus B times by the height divided by 2. So now all I need to do is substitute. A is 5. Add B, which is the other side, parallel side, going off side here, but times by the perpendicular height. The perpendicular height is 4 centimetres. Sometimes in your exam, they will try to trick you, Year 10. They will try and give you a length of a side. Always remember, it's the perpendicular height from top to bottom. So I'm going to times that by 4 and then divide by 2. Yeah, a very tricky formula to find the area of a trapezium. As long as you can try and remember the sum of the parallel sides multiplied by the height and half it. Okay? So once you've found the area of the cross-section, the front face, all I need to do is times it by 7, the length. Because remember, to find the volume of a 3D shape, it's area of the cross-section multiplied by the length. Okay, I'll unpause you now. So there's the formula, so I'll bring it down here. So it would be 5 plus 9.7 times by 4 divided by 2. Okay, does that, you look pleased with yourself. You're very welcome. Does that make sense, lads? Yeah, so the area of a trapezium, you've definitely got, like, yeah, I can see that you've got it down, well done. Fine. Right, let's have a look at the data. I can still see that some of you are getting it wrong, all right? Let's just go back to it. So let me just write the formula for you, and then what I need you to do is substitute, all right? Because I'm seeing red now, the danger zone. I don't want to see the danger zone. Okay, so again, A plus B, and we're using algebra because, again, it can change. That's A, whatever measurement that is, you substitute it. That's B, okay, whatever measurement that is, you substitute it, times by the height, and then divide by 2, okay? So what I want you to do is substitute A, B, and H for what it is in your calculator, divide by 2, and then you're going to times it by what? No, you don't want to answer. I'm saying, not the height, the length. So I'm going to times, when I found the area of the cross section, I'm going to times it by the length, which is 7. Okay? Madison, you had a question.
Yeah, I did that, but it's still right.
So the volume of the trapezium. So 205, but did you get 205.8?
I think I forgot to put my brightness.
Yeah. So I'm just working with Maddie here, and maybe some of you in your calculator are forgetting to put the brackets in. So your calculator's not doing bid mass, yeah? You've got to stress to your calculator that I want you to do this first. I want you to add the parallel sides up first. And then once you've done that calculator, can you times it by the height? And then divide it by 2. Yeah. So always remember to bracket the sum of the parallel sides. All right? So you should, yeah, I'll leave that with you. Ishal, how can I help? Right, we're going to be packing away in 3 more minutes, guys. All right, so a couple more questions. We can get them in. Couple more questions. I'm just working with Emily and Ishal. I'll be 1 second. Okay? Would you, in fact, let's have a little look at this. Okay? Because again, this is probably the question on your paper with you being higher. So I prefer everybody's attention on this, really. Because you've learned now the area of a cross section times by the length. Calculate the volume of the cuboid in cubic meters, all right? So what we need to have a look at is, this isn't here, okay? So we've got all the outside. So what we need to do first is we need to find the volume of the inside cube, all right? So what's the area of this rectangle? So inside, we're going to do 5 times by 4 equals what? 20. All right. So that's the area of this cross section. Okay. What's the height? 6. Well done, because opposite sides are the same. So I'll times that by 6 equals 120 centimeters squared. Okay. Now we need to find the area of the cross section out here. All right. So what's the base here? Well done, because opposite sides are the same. So this must be 14. So using your calculators, 6 times 14. I'm not doing all the work for you. Say again. 84. Okie dokie. Right. So now I've got the area of this face and the area of this face. What I need to do is multiply this by the length. So again, how many of these rectangles can fit into this 3D shape? So what is the length of here? What's this? 9, again, opposite sides are the same. So that's x equals 9. So I'll do 84 times by 9. You'll get that answer. Again, I'll leave that to you. I'm not doing the work for you. You've been given the face of this, and what's the height of this? So I'm going to be looking at other sides, so times that by 6. So whatever you got here, take this away. So this, subtract the 120 centimetres squared. Oh, sorry, bear with me 1 second because I need to get rid of the volume. Times that by the 6. Sorry, 5 times 4. Sorry, yes, and then times by the 6. Sorry, I was going into a little bit of I was teasing my own brain. So yes, and then take that away from that one, okay? Right, it's 5-2, year 10. I just want to say a fantastic effort today. So what I want you to do is finish the question you're doing. I want you to restart your LBQ tablets, and then I want you to put your books, your calculators, and your tablets to the ends of the desk. I just want to say a massive effort today and a really good try. You've worked really hard today and I'm so pleased with your progress. Put your hands up if you know how to find the volume of a cylinder. Ishal, what's the formula to find the volume of a cylinder? You've been put on the spot, I understand. Do you want some time or shall I move on to somebody else? Move on to somebody else, go on, I can always rely on a saying. Times by height. Pi times by radius squared times by height. What about a cone? I've got a feeling nobody's going to put their hand up. Italia, thank you so much. How do I find the volume of a cone? Bang on. Really well done. Fantastic effort. Stand behind your chairs for me, please. No, it's all right. I know it's your last lesson today, so they usually will, but I just want the cameras to be able to see your amazing faces. Right, facing forward. Thank you so much. So just a quick reminder, year 10, you are not in school tomorrow. It's inset day for teachers, so you get an extra day off. So I just want to say, you get an extra lie-in. We don't. Boo. Yeah. So I just want to say as well, also, because we're going into a new topic after half term. So I want you to get a bit of revision done. I don't want to be the bearer of bad news. I know it's your holiday and you need rest. You're tired. We're halfway through the year. But again, you get that revision in, we're going to start getting our grades up there. And that's exactly what I want for you all. Okay? I just want to say a fantastic effort again today. Really well done. Have a lovely evening and a half term. Take care, guys. Thank you again. Thank you. Thanks, Connie. See you later, guys. Thank you. Take care. See you later. Thank you again. See you later, guys. Take care. See you later, Gemma.